Now let's proceed to the Cauchy-Euler equation. So the Cauchy-Euler equation is this form. So the coefficients a sub n, a sub n minus 1 up to a sub 0 are constants. So the observable characteristic of this type of equation is that the degree k is equal to n minus 1 up to 0, 1 of the monomial coefficients x to the k matches the order of differentiation. So for example, if we have this second order differential equation, we have ax squared and the derivative of y plus bx times the first derivative of y plus dy is equal to 0. For this type of equation, we try a solution of the form y is equal to x to the m, where m is to be determined. Getting the second derivative of y, substitute it here, first derivative of y, and then y, we will arrive with this equation. So the auxiliary equation is this one, or rearranging the equation, we have this. So there are three cases. We have distinct real roots, repeated real roots, and conjugate complex roots of this following form. For example, we have this equation, then we'll find the general solution. So our solution is of the form y is equal to x to the m. So we need to find the value of m. So getting the first derivative and second derivative of y, first derivative equal to m x m minus 1, second derivative is m times m minus 1 times x to the m minus 2. So substituting these equations to the second order differential equation, we have x squared times m minus 1 x to the m minus 2 minus 2x times m to the m minus 1 minus 4x to the m equal to 0. Now, for this term, x squared is cancelled. We are left with m minus 1 x to the m. For this term, x is cancelled. 2m x to the m minus 4x to the m equal to 0. Arranging this equation, x to the m squared minus 3m minus 4 equal to 0. Our auxiliary equation, m squared minus 3m minus 4 equal to 0. So our m1 and m2 equal to -1 and 4. So our general solution, the form c1 x to the -1 plus c2 x to the 4th. The next example, we have this second order differential equation. So again, our solution is of the form y equal to x to the m. first derivative m x to the m minus 1. Second derivative m times m minus 1 times x to the m minus 2. So the same step as before, we have 4x squared times m times m minus 1 x to the m minus 2 plus 8x m x to the m minus 1 plus x to the m equal to 0. We have 4m times m minus 1 x to the m plus 8m x to the m plus x to the m equal to 0. So we have 4m squared 4m x to the m plus 8m x to the m x to the m is equal to 0. We have x to the m 4m squared plus 4m plus 1 equal to 0. So our auxiliary equation is 4m squared plus 4m plus 1 equal to 0. We have 2m plus 1 squared is equal to 0. So our m1 is equal to m2 equal to negative 1 half. So our general equation is x equal to c1 x to the negative 1 half plus c2 x to the negative 1 half times ln of x. So for our next example, we have this initial value problem. Again, we have y is equal to x to the m. First derivative is m to the m minus 1. Second derivative is m times m minus 1 times x to the m minus 2. We have 4x squared times m times m minus 1 x to the m minus 2 plus 17 x to the m equal to 0. Combining like terms and factoring out x to the m, we have x to the m times 4m squared minus 4m plus 17 equal to 0. Our auxiliary equation, we have 4m squared minus 4m plus 17 equal to 0. Now our roots here are imaginary, so we have m1 and m2 equal to 1 half plus minus 2i. So for alpha equivalent to 1 half, or beta equivalent to 2. So our general equation is equal to x to the 1 half times c1 cosine of 2 ln of x plus c2 sine 2 ln of x. Now getting the values for C1 and C2, first we need to get the first derivative of this equation. The first derivative of this function equal to, so I was using the product rule, 1 half x to the negative 1 half times C1 cosine of 2 ln x plus C2 sine of 2 ln x plus x to the 1 half times negative C1 sine of 2 ln x times 2 over x plus C2 cosine of 2 ln x times 2 over x. Using the initial values, we can solve for C1 and C2. Now for C1, when y of 1 is equal to negative 1, we have negative 1 equal to, so when x is 1, y is equal to negative 1. 1 to the power 1 half times C1 cosine of, so ln of 1 is just equal to 0 plus C2 sine of 0. So our C1 just equivalent to negative 1. Now for our C2, y prime of 1 is just equivalent to negative 1 half. So we have negative 1 half equivalent to half times 1 to the negative 1 half times, so C1 is negative 1, so we have negative cosine of 0 plus C2 sine of 0 plus 1 to the power 1 half negative C1, so we have positive sine of 0 times 2 over 1 plus C2 cosine of 0 times 2 over 1. So this is 0, 0. So we have negative 1 half equal to negative 1 half plus 2 C2. So our C2 equal to 0. So the solution for this initial value problem, we have y is equal to negative x, so 1 half cosine of 2 ln of x.